Good morning, everyone. Yeah, very good morning. How are you? Yes, I'm also good. So, shall we begin the session? Today's topic is the ER diagrams, entity relationship diagrams that can express. Now, in the last class, we have finished with the entities, keys, constraints. Now, we focus on how to build a diagram, what are the tools that is used. Till now, we have studied about various structure, various things. Now, how it is built, that is the ER diagram. This can express the overall logical structure of a database graphically, and this ER model are simpler and clear qualities that may well account in large part for the widespread use of the ER models. That means whenever we are using the entity relationship model, this can express the overall logical structure of a database graphically. And these diagrams are simpler and clear. Quantities are very clear much or clear about that is used in the ER diagram that may also well account in large part for the widespread use of the ER diagrams. Now, next is the basic structure. So ER diagram consists of the following major components. One is the instructor, one is the student. So there is the ID, name, salary, then advisor, ID, name, total credit. So instructor have a three fields, three attributes. We can say ID, name, and the salary. And then student have a three attributes, ID, name, and the total credits. And what is the relationship between these? That is the advisor. This is representing in the diamond box. Now this is a process box. This is the entity. These are the attributes. Three are attributes. One is the entity name. This is the entity. These are the attributes. So this ER model corresponding to the instructors and the students. Now let's take one by one. First is a rectangle that is divided into two parts. One represents the entity sets. First part, which is in this notebook, is shaded as a blue, contains the name of the entity set. Second part contains the name of all the attributes of the entity set. So first part is in a blue that shows the name of the entity set, then attributes of the entity set. Then diamond that represents the relationship sets. Yes, relationship means what is the relationship between these two entities. Then undivided rectangle that also represents the attributes of a relationship set. Then that are the part of the primary key that are the underlined. Then lines that link entity set into the relationship sets. Alright. When we talk about the undivided rectangle that represents the attribute of a relationship set, and these attributes that are the part of the primary key are also underlined over here. That is a part of the primary key. This is ID is the primary key for the instructor, ID is the primary key for the student. Then links that entity set into the relationship set. So this is a line that links into the entity set or relationship set. Then dash line that link attribute of a relationship set to the relationship set. Then double line that indicate total participation of entity in relationship set. Then next is a double diamond that represents the identifying relationship set linked to weak entity set. Now consider the ER diagram, which consists of two entity sets. One is the instructor, one is the student, related through a binary relationship set advisor. And the attribute that is associated with the instructor are the ID, name, and the salary. So there are three attributes over here: ID, name, and the salary. And the attribute that is associated with the student are name, ID, and the total credit. This represents the attributes of an entity set that are the members of the primary key that are underlined. And if a relationship set has some attribute that is associated with it, then we enclose the attributes in a rectangle. Rectangle in the sense, whatever the process that is used in the rectangle, that is a rectangle, that is a process. With a dashed line to the diamond representing that relationship set. So we have a date descriptive attribute attached to the relationship set advisor to specify the date on which an instructor becomes the advisor. There is the instructor, there is the student. Instructor have ID, name, and the salary. Student have ID, name, and the total credit. then date, advisor. So this is the year diagram with an attribute attached to a relationship set. Now this is the year diagram that is with an attribute attached to a relationship set. Now this is the A part. There is the instructor, student, advisor. Then B part the same. C part is also same. So this is the relationship one-to-one because there is only one arrow in between. Then one-to-many, there is only one instructor and there are many students. Then many-to-many, there are many instructors and many students. So there is the relationship difference. One is one-to-one, one-to-many, and many-to-many. Now, mapping the cardinality, how to map between the instructor and the student entity set. That may be one-to-one, that may be one-to-many, that may be one-to-one, or many-to-many. So to differentiate among these types, we draw either a directed line or an undirected line. So either use the arrow line or the normal simple line that between the relationship set. So whenever I denote the arrow, that is a one relationship or the many relationship in the entity set in question. So first is the one-to-one. So we draw a directed line from the relationship set advisor to both entity set instructor and the student. This indicates that an instructor may advise at most one student and student may have at most one advisor. Maximum is one, not above that. Then one-to-many. So we draw a directed line from the relationship set advisor to the entity set instructor and an undirected line to the entity set student. This indicates that an instructor may advise many students, but a student may have at most one advisor. Then next is many-to-one. So we draw an undirected line from the relationship set advisor to the entity set instructor and a directed line to the entity set student. That is a many-to-one. This indicates that an instructor may advise at most one student, but a student may have many advisors. So this is one-to-one, one-to-many, many-to-one. So there are many instructors and there is only one advisor. That is known as the many-to-one relationship. Now, in case of many-to-many, many advisors, many students, many instructors. Just read out these things. Let's start. Any doubts, anyone? Till here, till the relationships one-to-one, one-to-many, and the many-to-many. Now, let's move to the next part. So, year diagram also provides a way to indicate more complex constraint. This is the easy constraint. Next one is the more complex constraint on the number of the times each entity participates in a relationship set. And a line may have an associated minimum and the maximum cardinality that is shown in the form of LH, where L is the minimum and H is the maximum cardinality. And a minimum value of 1 also indicates that there is a participation in the entity set in the relationship set. That is, if one entity occurs in at least one relationship, that also gives a relationship of more than one relationship. And a maximum value of 1 indicates that the entity participates in more one entity, while a maximum value indicates or asterisk indicates no limit. Now let's take another example. So there's a line that shows in between this. This is 7.10. So whatever the line that shows, so this is 0, asterisk, then 1, 1. This is asterisk means many. So this is many relationship, and there is a 1, 1. That is a one relationship. So this is the has a cardinality constraint of 1, 1. That meaning the minimum and the maximum cardinality of are both 1. That is, each student have at least, or we can say the exactly one data that is available. So each student will have exactly data that is used in the entity sets. And the limit 0 asterisk on the line indicates that there is a line between the advisor and the instructor that indicates that an instructor can have 0 or more students. Therefore, the relationship advisor is one-to-many from the instructor to the student, and further, the participation of student in advisor in total. That implies that a student must have an advisor. And it is very easy to misinterpret the zero asterisk on the left edge and think that the relationship advisor is one-to-one from the instructor to the student. This is exactly the reverse of the correct interpretation. And if both the edges have a maximum value of 1, so the relationship is 1-to-1. And if we have a specified cardinality limit of 1 asterisk on the left edge, so we could be saying that each instructor must advise at least one student. This is at least. So this is a diagram that could alternatively have been drawn with a double line from student to advisor and an arrow on the line from advisor to the student, instructor, and in place of the cardinality constraint shown. So this alternative diagram would enforce exactly the same constraint as the constraint shown above over here. The next one is the complex attribute. So this shows how the composite attributes can be represented in the ER notation. So this is the composite attribute name for the component attributes, that is first name, middle name, or middle initial, last name, that replaces the simple constraint name of the constructor. That means, yes, name have a different categories, name have a subparts also, that is the first name, middle name, last name. So you can either give name or both three, because these are the component attributes. So we can give only the name or simply attribute, that is the name of the instructor. Let's take another example. Suppose we were to add an address of the instructor entity set. So if I want to add the one more attribute, that is the address, so address can become defined as a composite attribute address with the attributes with a street, city, state, this one. So let's take with the example. So this contains, so this ER diagram contains or with a composite, multi-valued and derived attributes. So one is the ID, then there is a name. Name includes three parts: first name, middle name, last name. Then address, that includes street. Now street also contains, that is a multi-valued or the composite attribute: street number, street name, apartment name. Then city, then state, then zip. Zip means zip code. Then there's a phone number that may be optional. We can give or we cannot give. Then date of birth, and then there's a function age. This is a derived attribute. With the ID, then name, then address, then phone number, then zip, then date of birth. So this street is itself a composite attribute, where the composite attributes are the street number, street name, apartment name. So this illustrates a multi-valued attribute for number that is denoted by the phone number, and the derived attribute age that is depicted by a age function. Now we indicate the role in the ER diagram by labeling the lines that connect diamonds into the rectangles. This shows the role indicator, whatever the role indicator we have. So that shows the role indicator that may include the course ID and the prerequisite ID between the course entity set and the prerequisite entity set. That prerequisite entity set may be the entity set that is not or that indicates that what is the course ID, that indicates what is the relationship between the row that connects with the diamond. The next one is a non-binary relationship set that can be specified easily in an ER diagram. It consists of the three entity sets: instructor, student, and the project, that is related to the relationship set project guide or project guide. One is a course, then there is a course ID, title, and the credits. Then there is a course ID, prerequisite ID, then there is a prerequisite. So this is the ER diagram with the role indicators. There is the project, then instructor, then student, then project guide. So we can specify some types of many-to-one relationship in case of the non-binary relationship set. Suppose a student can have at most one instructor as a guide on the project. So this constraint can be specified by an arrow. So this can be specified by an arrow that pointing to the instructor on the edge from the project guide. So we permit at most one arrow out of a relationship set. Since an ER diagram with two or more arrows that can be specified with the non-binary relationship set that can be interpreted in two ways. Now suppose there is a relationship set R between entity set A1, A2 and AN, and the only arrows on the edge to the entity set is AI plus 1, I plus 2 till AN. And the possible interpretations are associated with the combinations of the A1, A2 till AI with the AI plus 1. That means the next element of the entity sets. So therefore, the primary key for the relationship R can be constructed by the union of the primary key of the A1, A2 till AI. And for each entity sets AK, I is less than K, then less than N, each combination of the entities from the other entity set can also be associated with at most one entity from the AK. And that is associated then forms a candidate. Now, each of these interpretations have been used in different books in the system. That depends on the, we can say the arrow, that depends on the relationship, that is the functional dependencies. Now, consider a section. Okay, just wait for 5 minutes, read out and okay. Now next one is the weak entity set. So till now any doubts? Now consider a section entity which is uniquely identified by the course identifier, that is a semester year section identifier. Now clearly the section entities are related to the course entities, and suppose we created a relationship that is a set course ID or set course between the entity set, section and the course. So these entity set shows the information in the secure course that is redundant, and since section I already have an attribute course ID which identifies the course with which the section is related up. That means which is attribute or which attribute is given with the redundancy to get rid of the relationship section course. However, by doing so, the relationship between the section and the course have become implicit in this attribute, which is not desirable, which is not fruitful. So there is an alternative way to deal with this redundancy is not to store the attribute course ID in the section entity, and not only store the remaining attribute section ID year and the semester that is used with the entities. That may be a weak entity, that may be a strong weak entity or strong entity set. So the notion of a weak entity set formalizes the above intuition. An entity set that does not have sufficient attributes to from a primary key is termed as a weak entity set. And this entity set that have a primary key is termed as a strong entity set. So for a weak entity set to be meaningful, it must be associated with another entity set known as or known the identifying code, the owner entity set. And every weak entity set must be associated with an identifying entity. That is, a weak entity set is said to be the existent dependent. And this is said to own the weak entity set that may be a framework that may be also designed with the weak entity that may be defined with the identifying relationship. That may be many to many, many to one, and one to many. From the weak entity set to identifying with the entity sets. And the participation of the weak entity set in the relationship is total. This identifying relationship set should not have any descriptive attributes, since any such attributes can instead be associated with the weak entity set. So in our example, the identifying entity set for the section course is course, and the relationship set course that associate the section entity with the corresponding course entity, that is the identifying relationship. So that does not have a primary key that can be used to differentiate among all entities, that is in the weak entity set, that depends on one particular strong entity. And this, the discriminator of a weak entity is a set of the attributes that allow this distinction to be made. For example, when I talk about the discriminator of the weak entity set, that consists of the attributes sec ID, year, semester for each course, and this will uniquely identify as one single section for that course. So this discriminator of a weak entity set is known as the partial key of the entity set. That is performed with the primary key of the identifying entity plus the weak entity set discriminator. And in the case of the entity set section, its primary key is course ID, section ID, year, semester, where course ID is the primary key of the identifying entity set, namely course, and section ID, year, semester differentiate the section from the same course. So there is a course, there is a section. So there is the course ID, title, credits, then there is a section course, section ID, semester, and the year. However, conceptually, the section is still dependent on a course for its existence that is made explicit by making a weak entity set. That is depicted by a rectangle like a strong entity set, but there are two main differences. One is the discriminator of a weak entity set is underlined with a dashed line, with a dash criteria that is used rather than a solid line. And the relationship set containing or connecting the weak entity set to the identifying strong entity is depicted by a double diamond. This is a single and a double. Now this weak entity set section depends on the strong entity that depends by the relationship that is known as the set course. There is an entity named as a course, and there are three attributes. One is a course ID, one is a title, one is a credit. There is again a section. There are three attributes. One is a section ID, semester, and the year. Now what is the relationship? That the section course has a relationship in between, and there are a double diamond. That means this is a weak entity set that is depicted as a double diamond that is used as a same course. Now there is a single arrow. There are the multiple lines that denotes which entity set depends on which set, that illustrates with a double line that indicates the total participation. Yeah, this indicates that how it is, or the arrow from the course ID or section ID to course indicate that each section is related with a single course. For example, when we say about the section entity that could participate in a relationship with a time slot, that identifying the time when a particular class section meets, that identifying or participate as an owner in identifying the relationship another entity weak entities. Yeah, that is possible to have a weak entity set with more than one identifying entity set. That is not hard and fast rule that there is a one entity set and there is only one possible way. And a particular weak entity set will be identified by the combination of the entities, one for each identifying entity set. So whenever we use the primary key of the weak entity set that consists of the union, that means a combination of the primary key of the identifying entity set. Now this shows the relationship between these. There is a course, there is a section, course ID, title, credits are the attribute, section ID, semester, year are the attribute. There is a section course, there is the relationship that is represented by the diamond box. Now, year diagram for the university enterprise. This is one of the examples. Now, let's see one example over here. This is the year diagram for the hospital management system. There is a treatment, there is a medicine, there is a patient. Now, these blue rectangular boxes are known as the entities. Treatment, patient, medicine, rooms, nurse, employee, receptionist, doctor, trainee, visiting, record, permanent. Now these are the various attributes that is denoted by the oval shape, sorry. And this is the relationship in between. There is a relationship, is a relationship. That denotes how one they work with each other in an entity set. That represents with the entity, that represents with the employee, that represents with the rooms.